All right, so let's talk about why even care about this. So, the biggest qualm customers have when adopting Gen AI is the accuracy of the system. 56% of AI users say it's difficult to get the right answers. And then 75% of people say the reason they don't use AI systems or adopt them is because they give the wrong answer or only partially correct answers. This has business ramifications as well. You guys read the Air Canada story. The chatbot basically made up some stuff based on support retrieval that gave a customer a $50,000 refund when he wasn't owed it. You know about this? And they actually legally were forced to pay the customer $50,000. So, RAG is extremely crucial to any Gen AI stack. We focus a lot on the LLMs, but, the retrieval aspect is just as important. So what we do with Vals now is pretty much just hoping the user gives you a thumbs down. I don't know about you, but I usually just refresh the tab and just skip if needed. I don't think anybody actually answers this. So we can do better than this. So today we're going to talk about how to do real-time evals and how to do deployment. So, let's start out with evaluation metrics, right? How do we actually measure how well our pipeline's performing? So the most basic metric, when some people talk about accuracy, you often talk about hit rate, right? So, we think about if I have if I retrieve my top 5 results, my hit rate at 5, and it's there, and I have all 5 there, we're gonna give it 100%. So this is really intuitive, but it's not great for LLMs because of the loss in the middle problem. So you can see here, after you drop past result 3, and then once you get to result 5 or 10, you're seeing a significant drop off in the truthfulness of your LLM and RAG application. So knowing the position of the ideal information is really crucial. So this is why I like to use MRR or mean reciprocal rank when I know there's a single piece of information. So this pretty much weights how high up the correct piece of information was. So if you have the right info in rank 1, you get 100%. 2 drops it down to 50%, and 3 and so on. So this is really easy to calculate. It gives you a really good it's a really good representation of how well your application performed. And the only con is that it's only works if it's a single piece of information. So there's also recall, which, basically it's very similar to hit rate, which is when you have multiple items. Again, very intuitive, good for just maybe an eye test, but doesn't tell the whole story. So NDGC, very common metric in existing search engines. This is really great when you have multiple results and you want to see how close were they to rank 1. So kind of dive into these metrics. Hit rate, very simple, very similar to recall. And then MRR and NDGC are what you really want to look at if you're trying to do a more in-depth evaluation of your system. So now diving into data sets. So an easy way to get started out, and most of you guys probably do this, we go to Hugging Face, they have the MTEB scores. MTEB is kind of the leading retrieval benchmark, and for all kinds of tasks for embeddings. If you run some of those models that score really high on MTEB, you'll quickly realize that many of them have just been trained on the evals, and when you show them novel data, they do terribly. So I definitely recommend using some newer data sets. March Ragnus from Tonic AI was really good. We have our acquired benchmark, which we've certified as a clean benchmark. We manually scraped all that data. And the Airbnb 10K data set is really good for financial tasks. There are some data sets like MS Marco where we actually noticed they're so old, they were generated by GPT-3. Your retriever actually will do a better job than what the data set counts as the right answer. So definitely be careful to avoid those. So generating your own data set is a great way to start doing this, especially if you have a domain specific task you're going to work on. So we'll kind of dive into how to do this. So first thing you want to do is generate some questions, right? So, you want to put your corpus together, take this LLM prompt, point it at each document one by one, and have it generate some questions based on the facts. This way you can tie that question to that chunk. This makes it really easy to do evaluations later on. Now, there is a caveat here. If you do generate answers, you can end up hitting a local maximum just because you've overfit your data set. So again, you always want to keep some data that you not use only for testing. Pretty standard ML practice, but I'll probably see people run into. Now, step 4 is going to be to prove the generated questions. This basically makes sure you don't have any duplicates or you don't end up in a situation where you have multiple questions that point to the same data or vice versa. Again, just keep your evals clean. Now, to dive into how to actually do evals. As we mentioned earlier, we have all those metrics, but the first thing you want to do is actually just start with BM25 and plain text search. You'd be surprised actually how well it performs compared to vector search. We actually have been guilty of this sometimes, but always start with plain text search as your baseline. Next step include things like vector search. You guys know all about this. And then do some kind of combination of both. Most vector databases like Pinecone, Willis, Meviate, all of them have some kind of way to integrate BM25. Very easy way to improve relevancy. And then secondly, add a post-processing step. So our product, semantic filter, is kind of a souped up re-ranker, or a traditional cross-equator re-ranker is also a great way to start. So best way to do this is probably to run an LLM if you have a large data set. You can pick your model. GPT-4 is going to give you the best, or Claude Sonnet 3, they're going to give you the best results. If you do have a really large data set, obviously not cost effective. We like to use Llama 370B. It's around 95% as accurate and much cheaper. There's also fine-tuned smaller LLMs like Rank Zephyr. They're good. They can give you a somewhat representative of how good your model is, but I would say your mileage may vary there. Now, when actually doing your LLM evaluation, you don't want to use a binary evaluation of true or false, just because there's going to be some piece of content that are somewhat relevant, right? And this can end up giving you poor results, just because your LLM will either mark something that is relevant, irrelevant, or vice versa. So using 3 different categories of highly relevant, somewhat relevant, not relevant is what you want to do, just because of how non-deterministic LLMs are. So here's kind of a prompt we put up for how we run evaluation. All this stuff is on GitHub as well. And then one caveat here: if you do have, I would always recommend starting with a smaller data set that you evaluate manually, just because there can be some drop off between a human and an LLM, no matter what you're using, especially for more complex questions. Like this is a question that we have in our acquired data set that the LLM just doesn't understand. It's a very complex question a user may ask. But just note that LLMs will not be 100% accurate in doing this. Now, diving into, that's great if you have a data set you're testing with. How do you do evaluations in real time? Kind of ties back to that first question I asked, right? How do you measure the performance of your system in the wild? So we talked about all those metrics, overfitting, but we can dive into this. So what you want to do is you want to build a live assessment architecture, right? So user runs a query, returns relevant docs, and you want to create a background task that's going to go and kick off this background LLM evaluation. And then you can set up alerts and all kinds of stuff there. So it's really important. A good example is user asks about roses, but the only information about dandelions, you're going to be alerted that hey, either part of our pre-processing failed, either part of our ETL failed, pre-processing's messed up, something in there, or embeddings model just has a blind spot. You kind of root cause all these issues. You also can A/B test different methods. If you try different chunk sizes, really great to make sure, see how that's performing in the wild. And then 2, on the business side, making sure customers are satisfied. And then 2, intercepting potential accounts that could churn if they get the wrong answer. Yeah, so that's pretty much it. All the stuff we talked about, that code is on GitHub. And then we also have a live demo of this that you can try on our site. Thank you.